what I'll get. The following video clip was extracted from my east-west light speed anisotropy experiment, which was based on Fize's ether drag experiment in 1859. The three frames of this animation show the consequences of blocking the returning beam 3 or the returning 1-2 source beam. The beams 2-3 and beams 1-2 interference patterns are identified. The beams 2-3 fringes are to the left of the screen. Those are the fringes that will be affected by the anisotropy. The outcome from that experiment was a null result. There was no evidence of an east-west light speed anisotropy. But I had very little confidence in that outcome. Did I really understand these interference patterns? The setup used for the Michelson-Morley experiment in 1880 can be used to demonstrate that the interference pattern I was using was valid for the task. The light paths can be analysed individually and simply by unfolding the two arms at the beam return mirrors and taking a laser beam source and half-silvered mirror with them. There will of course be no interference patterns generated by the beams from two different sources. Before I go any further, the integrity of the half-silvered mirror needs to be tested. Take note of the double image when the laser beam is reflected off the glass face. This half-silvered mirror is the point of focus for the two beams of the unfolded MMX device. One leg is pointing east, while the other points to the north. The laser beam is initially reflected off the silvered face of this half-silvered mirror, losing 50% of its power, and then off the inner glass face at the far side. The glass face reflection is very weak and can be ignored. The remaining beam loses 50% of what's left of its power when it passes straight through the target mirror to a screen which is mounted directly behind it. Now for the east pointing beam. The laser beam initially passes through the half-silvered mirror and reduces in power by 50%. It then travels to the target mirror. The beam is initially reflected at 90 degrees off the glass face and then off the silvered face of the target mirror. The glass face reflection in this case is very significant. The two beam elements generated here give a very robust interference pattern. In this clip, Beam north is focused midway between the two elements of beam east. The interference pattern will fade in and out if the length relationship between the two beams varies. But the interference pattern itself only gives a rough indication of how thick the half-silvered mirror glass is. A reliable fringe shift will only occur if the trajectory of beam north is shifted to the outside edge of the strongest element of beam east. To convert to the unfolded view of Fisher's ether drag experiment, all I need to do is shift the screen from the south side of the half-silvered mirror to the west side and turn the half-silvered mirror by 180 degrees. The beam functions are reversed. Beam north now generates the interference pattern. Beam east is now comparing with the strongest element of beam north. Exactly as it was in my east-west lightspeed anisotropy experiment. But the null result is very much in conflict with Fisher's positive result. This animation demonstrates why. Local to the Earth, the propagation base for light is clearly the ECI frame. According to Fisher, the east-flowing water will drag the light propagation base along with it to a greater extent than the water flowing west. For a 10 metre per second water speed in my device, I would expect a fringe shift of 0.184 of a 634 nanometer wavelength. That's what a Fisher device of the same proportions would give if the water flow direction was reversed. In the quest to resolve the conflicts, I removed every potential cause. I replaced the half-silvered mirror with a beam splitter where there would be no feedback problems, and I separated the two light beams that would normally share the same water tube. The laser beam is initially split into two parallel beams 12mm apart, which travel along two water-filled tubes where the water is flowing in opposite directions. The beams are recombined to follow parallel paths which diverge into each other enough to generate an interference pattern by the time they reach the screen, which has been tilted to be almost parallel with the beam trajectory. The interference pattern is only magnified in the plane of the two interfering elements. Using two completely different light paths makes this device very sensitive to physical distortion. I wasn't expecting too much here. An 8.5 horsepower petrol-powered centrifugal water pump proved to be absolutely useless for the water flow control. I replaced the centrifugal pump with the twin screw pump from my original setup and attached a 6 kilogram flywheel to the crankshaft of the engine. The water flow rate was still all over the place. The next step was to make a small torque converter to connect between the drive motor and pump to smooth out the bumps. The torque was transferred via a water medium. A trickle of water was maintained through the unit to stop the water boiling. Here's an example where the engine is idling and the torque converter speed is varied between idle and zero. The fringe wobble was still much greater than the fringe shift I was trying to identify. This is where I threw in the towel. The next step was to remove the rogue interference pattern in my original experiment. Details of that experiment can be found here. The beam divergence from source to screen using my helium neon laser is less than 6 mm. A 6 mm thick half-silvered mirror was enough to separate the beams so they wouldn't interfere. The two truly interfering elements can now be properly compared. The tilted screen is now used to magnify the interference pattern. The screen can be rotated by 180 degrees around the beam axis so that an alignment with the compare angle between the beams can always be achieved. It's around 10 degrees off horizontal in this case. This setup was used to generate the next clip. In the video clip, one flash indicates that the unit is now stable and the water flow is east. 2 flashes and the water flow is west. 3 flashes indicates that the unit is moving to the next target. The 2 beams that will interfere are set below the 2 bright spots on the screen, which result from the primary beam reflecting off the closest water tube window, reflecting off the glass face and the inner silvered face of the half-silvered mirror. The missing bright spot is beyond the screen limit. And the picture is inverted as well because the camera is upside down. There's still no sign of an east-west light-speed anisotropy. It's now time to test the validity of Fizeau's experiment. All I need to do is reverse the water flow direction. That was a simple task. And there it is. Reversing the water flow direction is a fairly substantial physical change. It would be very difficult to rule out physical distortion to the device as the cause. The fringe shift can be accounted for if I apply a 20-gram sideways load on the copper tube leading into or out of the water tube on the laser end of the device. Such a distortion would be evident in the global picture though. But the same fringe shift occurs for every possible compare angle scenario. There's no doubt that this phenomena is caused by length relationship changes between the two beams. I'm left with only one answer here. The laser beams lose a substantial amount of energy on the journey through the water tube, which can only be caused by an interaction between the beams and the water. In my east-west light-speed anisotropy experiment, since there's no detectable anisotropy, that interaction remains constant for all pointing directions. Reversing the water flow is an entirely different ballgame. The fact that both beams travel through the same water tube is very significant as well. Each beam affects the environment of the other, which will further retard the progress of each beam. Fizeau's experiment shows the consequences of light beams travelling in opposite directions through a liquid medium which is in motion relative to the light source. It doesn't lend much support to Fresnel's hypotheses or anything else. The Michelson-Morley experiment null result proves that the local propagation base for light is the ECI frame. My null result proves that an east-west light-speed anisotropy is beyond our detection capability. No sensible universe would have a problem with any of this. Thanks very much for your time.